Okay, let's just dive right into this explainer. Today, we're tackling what is literally the most universal frustration every single programmer faces. I mean, whether you're writing your very first Hello World script or you're deploying massive enterprise software, you're gonna deal with broken code. So we're gonna look really closely at what's actually happening when the computer just flat out refuses to cooperate with you.
Look, we've all been there. You carefully type out your logic, you eagerly hit that run button, and boom, you're greeted by this massive, intimidating wall of red text. It's so discouraging, right? But today, we're going to totally reframe that experience. We shouldn't look at this as a failure. Instead, let's view it as a strict, three-part obstacle course that your code just has to navigate. Figuring out why your code failed? Well, that's entirely about understanding which specific hurdle it tripped over.
So here's our roadmap for the explainer. First, we'll map out the code obstacle course. Then, we'll break down the three hurdles: compilation errors, runtime errors, and presentation errors. And finally, we'll wrap up with your ultimate error fixing strategy.
All right, let's kick things off with Section 1, the code obstacle course.
Let's trace the actual journey a piece of source code takes. Diagnosing an error is pretty much entirely about knowing which of these three chronological steps tripped up your code. You've got compile time right at the start, runtime during execution, and finally the evaluation step. Every single error you encounter, it belongs to exactly one of these phases.
Moving right along to Section 2, Hurdle 1, Compilation Errors.
So this is the very first major roadblock you absolutely have to clear just to get off the starting line. A compilation error happens strictly before execution. Because your code violates the language's syntax, or maybe its type rules or structural requirements, the compiler basically throws its hands up in the air. Absolutely zero executable file is generated. Your code never even started running.
So what actually trips the compiler up here? Well, we're usually talking about simple typos and grammatical mistakes. Think missing semicolons, undeclared variables. Maybe you misspelled some core keywords, or you've got mismatched data types.
To make this a bit more concrete, imagine you declare a variable as an integer, right? But then you try to assign the word hello to it. You've just created a type mismatch. Or say you just forget a single closing bracket. The compiler can't parse your logic tree at all, and the whole translation process just stops dead in its tracks. Literally no execution for you today. Okay, next up, Section 3, Hurdle 2, Runtime Errors. Let's say your grammar was completely flawless and you pass compilation with flying colors. The really interesting juxtaposition here is that with a runtime error, your code is actually syntactically perfect. An executable file was created, but it crashes unexpectedly because it tries to do an illegal or impossible operation while it is actively running. These are the fatal flaws in logic or resource management that only reveal themselves once the program is actually moving. We're talking about the absolute classics here: mathematical division by zero, accessing arrays out of bounds, dereferencing null pointers, which is basically asking the computer to stare into the void, or, just simply running out of memory. Think about it like this. The compiler has zero grammatical problem with 10 divided by 0. The syntax is totally fine, but when the CPU actually tries to execute that math, it panics. Similarly, if you have an array with a size of 5 and you ask the computer to look inside position 10, you're asking it to look inside a box that doesn't even exist. The whole program just collapses mid-run.
Now on to Section 4, our final hurdle, Presentation Errors.
Oh man, this final hurdle is just uniquely infuriating, especially if you spend time practicing on platforms like LeetCode or HackerRank. A presentation error happens entirely after execution, during the evaluation step. Your executable ran to completion. Your underlying logic was literally 100% correct. However, your output formatting didn't perfectly match the extremely strict expectations of the automated grader. The causes for this hurdle can feel incredibly petty, but they are absolutely vital to understand because automated graders are totally literal. Presentation errors are triggered by the smallest things: extra spaces, missing new lines, slightly incorrect capitalization, or even invisible trailing spaces at the end of a line. Your logic is totally right, but your formatting is just a tiny bit off. Imagine the correct mathematical answer is just the number 5. Being a helpful, friendly programmer, you decide to output the text answer 5 to make it nice and human readable. But the system expected just the digit 5. Adding that helpful text completely ruins the strict alignment the platform expects, and bam, presentation error. You did all the really hard logic correctly, but you failed on the aesthetics.
All right, bringing it home with Section 5, your error fixing strategy.
We've identified the villains in this obstacle course, so let's arm you with a diagnostic framework to actually defeat them. If you don't even get an executable file, it's a compilation error. Your strategy is to go check the exact line numbers the compiler gives you to hunt for syntax typos. Now, if an executable is produced but it crashes mid-run, that's a runtime error. Your fix there is to add bounds checking, validate your inputs, or double-check your memory safeguards. And finally, if it runs fully but the grader rejects it, presentation error. You gotta compare your output against the test cases byte by byte, obsessing over every single trailing space. If you track the exact timing of the error, you will instantly know which strategy to deploy.
So I want to leave you with a question to really ponder. Instead of getting mad at the red text on your screen next time, think about what it reveals. Which of these three errors, compilation, runtime, or presentation, do you think is secretly teaching you the most about how computers actually think? I challenge you to look at these frustrating errors not as roadblocks designed to annoy you, but as strict, highly literal mentors. They are literally forcing you to learn the precise, rigorous language of pure logic. Master this obstacle course, and you master the machine. Thanks for joining me on this explainer, and hey, happy coding!